Welcome to CHST science lesson. In this lesson, we will be revising P1 part 2. Here's the bigger picture. In last video, we have revised about energy stores and law of conservation of energy. In this video, we will learn about kinetic energy, gravitational potential energy, elastic energy, and dissipation and efficiency. By the end of this video, you should be able to calculate the efficiency and power. So what is kinetic energy? Everything which is moving, it has kinetic energy. All moving things have kinetic energy, but the amount of energy they have is not just dependent on how fast they are moving. It also depends something else, which is very important to learn about. So kinetic energy depends on some other factor. So what about this? The kinetic energy of an object has dependence on mass and speed or velocity. The mathematical equation for kinetic energy is here. 1 over 2 times mass times velocity square. And this is the relationship between kinetic energy, mass, and velocity. And we can use this equation to calculate some kinetic energy in joules. Here is one example. A car with a mass of 1500 kilogram travels at the velocity of 20 meters per second. What is the kinetic energy of the car? So first of all, we should know what is given to us and what we have to find out. So kinetic energy is equal to half times mass times velocity square. We are given mass and we are given velocity. Some people do mistakes. They forget to take the square of the velocity. So do not miss the square. When you calculate it, the answer will be 300,000 joules, or you can convert it into kilojoules. What is gravitational potential energy? So from this picture, we know when an object is lifted up, so the energy transfer from whatever is doing the lifted to the object. So the energy due to its height is called the gravitational potential energy. So that object retains that energy until it drops. In this example, you can pause the video and discuss with your partners which books have gravitational potential energy, which book has the most gravitational potential energy, and which book has the least gravitational potential energy. Well done. Yes, all books have gravitational potential energy because all of them are placed on the shelves. The book B has the most potential energy because it is heavier and it is on the height, and book C has the least gravitational potential energy. Well done. Now discuss these two questions with your partner. Yes, well done. If you move book C to upper shelf, then definitely it will gain gravitational potential energy because of the gaining height. And if you move book B, move down to the lower shelf, it will lose gravitational potential energy. So there must be more to gravitational potential energy. Gravitational potential energy depends on its weight and its height. You know, weight is a force, so we can write down this equation in terms of force and height, and also in terms of mass. So weight equals mass times gravitational field strength. So we can replace the weight with the mass and gravitational field strength. So the new form of the gravitational potential energy equation is equals to mass times gravitational field strength times height. And mathematically we write down EP equals mgh. On the planet Earth, the gravitational pull is 9.8 Newton per kilogram. So, which is easier? If you were to lift this 20 kilogram dumbbell above your head, would it be easier on the planet Earth or on the moon? Obviously, it depends on the gravity. So where, if it is on the planet Earth, the planet Earth has more gravity than Moon, then this dumbbell will feel heavier. The mass remains same everywhere. On the Moon, its mass will be 20 kilograms, but it will feel lighter due to less gravity on Moon. Based on the equation, we are going to calculate gravitational potential energy. A person lifts a 50 kilogram box onto a shelf, which is 2 meters high. How much gravitational potential energy does the box gain? If we consider the gravity is 10 meters per second square. So by using the equation mgh, mass times gravity times height, so 50 times 10 times 2, which is equal to 1000 joule. The third important type of energy is elastic energy. So elastic potential energy is the stored energy as the result of an elastic object being stretched or squashed. So there are so many examples of stretching: rubber band or springs, springs in your bed, springs in your sofa, springs in your pen. What type of energy does the elastic potential get transferred back into when the rubber band is released? So it is holding gravitational potential, it is holding elastic potential energy, and when you release it, it will move into as a kinetic energy, and some of the energy will be moved as a um, move to the surrounding. So the equation for elastic potential energy is half times spring constants time extension square. What does it mean by spring constant? Spring constant is the capability of a spring to stretch, because every spring is made out of different material and it has different capability to stretch out. So of every material would have different spring constant. So now by using this equation, we need to work it out. Here are some examples. So first examples, a 1.2 meter spring is stretched and ends up at the length of 1.9 meter. The spring constant is 2.6 Newton per meter. How much elastic potential energy is stored? First of all, we will use the equation half times K times extension square. And these are the values. So you will get 0.637 joules. Here is another example. You can pause this video and try the workout of this equation. Okay, let's have a look for the answer. Well done if you got the correct answer. Right, now we have learned about three types of energy: kinetic energy, gravitational potential energy, and elastic potential energy. Now I will give you some questions, and in each question there are learning, challenging, and extreme levels. So you have to choose your level according to your confidence. So you have 10 minutes to do these questions. You can start either from learning and then you can go for challenging and extreme part. So pause this video, choose your challenge level, and then move on. We will mark the answers at the end. Now, second question. You can pause the video and choose your challenge. You can pause the video and choose your challenge. We will see the answer at the end. Here are the answers of your questions. You can mark your answers and then we can move on. Right, now based on energy transfer, so as we have seen in the video 1, when energy when energy starts from the input, then it uses pathways and it transformed into different forms of energy. So sometimes it is transformed into the useful energy, and sometimes the energy is being wasted or being dissipated. So to calculate the efficiency, we should be well aware of what energy is a useful energy and what energy is being wasted. So here is an example. So you can see we will describe the situation before and after in terms of what is reacting, what is happening to the amount of energy in the various energy store and why. So before, unburned fuel, so there is more oxygen, cold soup. So chemical energy is more than energy in thermal store because the chemical energy is not being used up yet. After, the fuel is less because it's been burned down, more carbon dioxide is produced. Hot soup, hotter air. So the chemical energy store is less, but thermal energy store is higher. So there are different ways in which we can reduce the wasted energy by using the bearings to change the sliding friction into rolling friction. By using lubricants between the surface, we can reduce the energy waste. By using insulation, we can reduce the heat energy loss. By using the smooth surfaces, we can stop the dissipation of energy. So efficiency is very important to calculate. So we know that efficiency is the amount of useful energy output from the device. So what values do you think we will need to know to calculate the efficiency of a device? One is amount of useful energy output, and second, total amount of energy input. So how much amount of energy is being transferred into useful energy? We will not consider here the waste amount of energy. So that's called the Sankey diagram, which helps us to understand the input energy, output energy, and useful and wasted energy. So on the left hand side of the arrow, where electrical energy is 100 joules, that is the input energy. On the right hand side, the top arrow, which is light energy 10 joule, this is the useful energy, and 90 joule is the wasted energy. So the arrow downward shows the wasted energy. And the equation of efficiency is useful energy output divided by total energy input. So by using this equation, we can calculate some efficiency of some questions. So in this question, you can see an incandescent light bulb is supplied with 100 joule of energy. It turns 17 joules into light. How efficient it is? So 100 joule is my input energy, and 17 joule is useful. So 17 divided by 1000 is 0.17 efficiency. But if I want to calculate the efficiency in terms of percentage, I need to multiply this with 100. So the efficiency of this bulb is 17%. Now you can pause this video, use this equation, and quickly calculate the efficiency of this energy saving light bulb. Good, well done. If you got the correct answer, the useful energy is 17 joules, total energy is 30 joules, and you calculated with 100 to calculate the efficiency, which is 57%. Here are some exam questions, some calculation in the table. I want you to pause this video for 5 minutes and calculate the efficiency, sometimes wasted energy, and fill in the table according to your calculation. Well done. If you come up with the answers, let's mark your answers. Well done if you got all answers correct. Now we are going to learn about power. So power is the rate at which work is done, how fast something is being done. The more powerful something is, the faster it can do work, and so the faster it can transfer energy. Mathematically, the equation for power is work divided by time, and the unit for power is the watts or joules per second. So 1 watt is equal to 1 joule per second. Let's do the example. So a lawn mower engine does 10 kilojoule of work in 10 seconds. So again, 10 kilojoule is not the standard unit. We have to convert this into joules. So 1 kilo means 1000 joules. So 10,000 divided by 10, 10 is seconds, and then the power will be 1000 watts. Here is another example. You can pause the video and carefully look on the units to calculate the power by using the equation. Well done if you got the correct answer. Again, I have to convert the units. Well, so 12 kilojoules means 12,000 joules, and 2 minutes means 120 seconds. So your answer is 100 watts. Well done. Now you can pause this video and fill in the space in the statements below to complete the sentence. Use the words, numbers, or units from the box provided, using each one only once. Well done. You can mark your answers now. Some other questions, you can fill in the equation by using the equation triangle. You can pause the video and do your calculations to complete the table. Well done. You can mark your answers now. Brilliant. Well done. So we are done for this video. Hopefully we have revised everything in P1. Good luck for your exam preparation.